All right. All right, so that says y equals 3 cotangent pi x over 4. All right, so it's cotangent, right, which means it's going to go up, left, down, right. I need to find a is 3, which is how high up it goes on the left and how low on the quarter point, how low it goes on the 3/4 point. The b is pi over 4, so the period is pi over b, which would be pi over 4. Keep, change, flip, and the period's just 4. So then I take this whole thing, pi x over 4, and set it equal to 0, and pi x over 4 and set it equal to pi. Multiply by 4, pi x equals 0, divide by pi, x equals 0. Multiply by 4, pi x equals 4 pi, divide by pi, x equals 4. Those are the middle two asymptotes. From the one on the left, you're going to subtract the period, so 0 minus 4. To the one on the right, you're going to add the period 4 plus 4. Now that's your first and your last as you move from left to right. So now I'm going to draw my grid. I only have one negative, then a 0, then a positive, then an 8. Those are my asymptotes. Halfway point between each. Okay, so the halfway point between -4 and 0 is -2. Between 0 and 4 is 2, and between 6 and 8 is 6. Keep going. Then, all right. So the ask him, just put him. Eyeball the quarter point and the 3/4 point, and then mark your A, which was what, 3. So on my y-axis, I want to mark 1, 2, 3, and 1, 2, -3. If it was tangent, we would start up on the left, or sorry, we would start down on the left and then work our way back up. But because it's cotangent, we reverse it. At the 3/4 point, we go, or at the quarter point, we go up to 3. At the 3/4 point, we go down to -3. And then you just want to connect those points. You can eyeball it, but you're going to mark it because that's how I know where your A should be. Yeah. You need these exact points. You need the halfway points to be exact. You need your asymptotes to be exact. But then the quarter point, you kind of just eyeball.
Do we have to mark everything? Like, do we have to mark the asymptotes?
So what you see there is what I should see. Yeah.
And we have to mark the 0?
Yep. Not the quarter and the 3/4, but the 0. So on your key point, like on if it was tangent, cotangent, I should see -4, -2 marked, 0, 2 marked, 4, 6 marked, and 8. All of those things should be marked. Yep. Yeah.
So the one that has a 0, you subtract the 4?
So the first one you find is actually the second one as you move from left to right. First one you subtract, second one you add. If you reverse that, you're going to get duplicate asymptotes. Like if I add to this one, I get this one. And if I subtract from this one, I get this one.
Yeah.
So you got to go out. Yeah.
So the smaller one
You subtract, right.
If there's an inversion on the test, or not like a phase shift, you have to like show vertical shift, sorry. Do you have to show both the original and
No.
vertical shift, or just the vertical shift?
Just the vertical shift. Yeah. Okay. Then, all right, this one is secant. So the first thing we're going to do is graph sine. Y equals cosine pi x plus 4. So my A is -1, which tells me it's going to go upside down. And then the absolute value of A is the amplitude, so that's 1. The B is what's in between the trig function and the x. So B is pi. The period for sine and cosine, 2 pi over B, 2 pi over pi, which is 2. Then I do my 0 is my first quarter point, is my first key point. 2 times a fourth, 2 times a half, 2 times 3/4, and 2 is the last one. So this one stays. This becomes a half. This becomes 1, 3 halves, and that stays as 2. There's no phase shift, so those are my key points. So I'm going to mark 0, 1 half, 1, 3 halves, and 2. So without the vertical shift, because I'm going to do that after I find the asymptotes. Remember, if there's a vertical shift, let that be the very last thing you do. I would plot cosine. Normally, cosine starts at the amplitude. So it would start at +1, go down, down, up, up like that. That's what my parent function of cosine would look like. But because it's a negative cosine, we reverse that. It starts at -1, goes up to 0, up to +1, down to 0, and back down, so that my original curve or my parent function would look like that. You need 4 asymptotes and 3 curves. So for cosine, I can literally just bring up the other 2 sides. And now I've got 1, 2, 3, 4 asymptotes. Now that I've found the asymptotes, I do my vertical shift. So before you do the parabolas, but after you do the asymptotes, you want to do the shift. So all of this is going up 1, 2, 3, 4, all the way up here. 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So my curve looks like that now, and from there is where I base the parabolas off of. So on your test, you could either do it in a different color. You could color in the final answer. You could use a highlighter. You could, I don't care how you distinguish its difference. You could literally be like, there's my answer. Okay, something like that. But on your actual test, there should be 4 asymptotes, 3 curves. Okay, the original should be there somewhere to give you some sort of a guide, but you could kind of like erase it. You do whatever you want to do. I'll pull out the colored pencils. You can make them different colors.
Or now having on test where x is not equal to 1.
Where x is not equal to 1.
Like if there's a phase shift, it's like 12x.
You're definitely going to get a phase shift.
Okay.
Yeah. Where you got to adjust them, you mean? Yeah.
For a vertical shift, is it 4 like additional points or is it 4 on the y-axis?
It's 4 from wherever it is, up 4. So like this is at 0, I go up 4 from there, it's there. From the wherever the point is. Yep, so this one's at -1, I go up 4 from there. Yep. So once I plot them, then I shift them. Yep. All right, so let's talk like logistics of your test. Are you good, Sophia? Yeah, okay. All right, so chapter 8, no, not 8, 6, sorry, crossing classes review. There are 19, such a horrible, ugly number, but there's 19 questions on your test. There's the part that is calculator, which is where you will start. And then there's the non-calculator.
How many are calculated?
Oh, I don't know the exact number. But yeah. Okay. So the calculator, what did I just say? 7? 7 questions calculator based. These are going to be the ones that are like straight up, use your calculator to find, probably not this easy, but sine of, and it's in radians this time. So like 2.5, or it will say, that's really hard to read, sorry. Or it will say, find the secant of 7.25, okay? That's a huge angle, but these are, all of it stays in radians the whole time. So you would literally hit sine of 2.5, and you'd get 0.598, so on and so forth. I think it says to round to 3. Secant would be 1 over cosine of 7.25. And you'd get 1.761, so on and so forth. Okay, stuff like that. Easy stuff, just don't screw it up. Like, don't reverse it, okay? Then came the, if I give you the trig function, you give me the angle part. That's where it got a little bit more confusing. So this is, it would say something like the sine of s equals 0.345. And you want to find angle s. And it will say from 0 to 2 pi, so it tells you that's radians, okay? And it will say, I think it's round to 3 again. So before I do that one, let's talk about how we do those ones, right? So this is the one where you go back to your unit circle. That's the trig function. You have to give the angle. So from here it's 0. This would be 3.14 because that's pi. And it would double back around to 6.28 because that's 2 pi. So everything's in terms of radians with a calculator will be decimal format like that, okay? It's not going to say pi. So if you're in the first quadrant, it stays. Theta equals s. That stays. First quadrant is first quadrant. Say again.
What would the answer be?
So like if this would be positive, this would be second sine, so we would do sine negative 1.345. And S1 option is 0.352. That's one answer though, because there are two quadrants where sine's positive, right? What two quadrants in which sine's positive? First and second, which means if it's positive, I always grab the angle in the first quadrant. That's one of them. But then I have to figure out where else it's positive. Sine is also positive in the second quadrant. So in that second quadrant, S is going to equal 3.14 times minus what you get from theta. So 3.14 minus 0.352. And the other option there is 2.788. So that's the two answers, two spots, two angles in radians in which sine would equal 0.345. If it's in the third quadrant, then I have to do theta minus 3.14. Yep. No, sorry, theta plus, we're doing the reverse. Theta plus 3.14 thing. Is that what you're going to say? Yeah. And then in the fourth quadrant, it's 6.28 minus theta. So let's say sine was negative. Sine of S equals negative 0.345. So these are the ones I said you could do differently, but my recommendation is treat it as though it's positive first. So I would do the same thing I just did, and I would get theta equals 0.352. That's your reference angle. That is not your answer, okay? Because that would give me a positive answer, and my question is negative. So now I go, what two quadrants is sine negative, which is where? Third and fourth, which means to find the one that's in the third quadrant, I would do 3.14 plus 0.352. And that's 3.492. That's one answer. And then I do 6.28 minus 0.352. And I get 5.928. So if it's negative, pretend as though it's positive to get your reference angle, and then figure out what quadrants it's supposed to be in and subtract it accordingly.
Can you do one more of this?
Yeah, I'll do a reciprocal function. First of all, the reciprocal ones, this is where the one doesn't come first, right? This is not 1 over tangent. This is tan negative 1 of 1 over, and we're going to treat it as though it's positive first. So second tan 1 divided by 3.5 gives me theta, and this is just my reference angle, 0.278. That would be, if it was positive, that would be one of my answers. I'd still have to find the other one, but that would be one of my answers. My original was negative though, so where is cotangent? Negative. Second and fourth. So second means take 3.14 and subtract what you just got from your reference, as your reference angle, so 3.14 minus 0.0278. Oops, 0.278. 2.862, that's one answer. And fourth quadrant, 6.28 minus what you just got as your reference angle. $6.002. I was just gonna say, what would happen if it was plus and minus 2.4? What does plus and minus even mean? It means it's gonna be in every single quadrant. So there's gonna be 4 answers for those. So I'm gonna find it in the first quadrant. First of all, it's secant, so I would do cosine negative 1 of 1 over, and I treat it as though it's positive first. So second cosine 1 divided by 2.4, and my S is 1.41141. That's one of the answers because that's the first quadrant angle, and if it's plus and minus, it's all 4 quadrants. So that's one of them, 1.141. Then I go second quadrant, 3.14 minus that. So 3.14 minus 1.141, 1.999. Third quadrant is 3.14 plus what I just got, 4.281. And fourth quadrant, 6.28 minus what I just got, 5.139. So our plus or minus means it's going to happen 4 times because it's going to happen in every quadrant. Questions on those? Here's the perk of those. You could check those. Like I could easily say, okay, find the secant of each of these and see if it gives me my question. So secant is 1 over cosine of 1.141, 1 divided by cosine 1.141. And I get 2.399. So it's not exact because we rounded it, but it's close. Then if I did 1 divided by cosine 1.999, it's pretty close. Negative 2.4, which is, it's plus or minus. 1 divided by cosine 4.281, and I get negative 2.39. 1 divided by cosine 5.139, and I get 2.4. So you can check all these to at least see that you're right.
So since it's plus and minus, if it's plus and minus, none of those answers will be negative?
Correct. Yep. When you check them, you mean, or when you go to write them on the line? When you write them on the line, if you're given an S, like if you're given an angle, it should never be negative because your reference is from 0 to 2 pi, so it's got to be positive. It should never be less than 0. It should never be bigger than 6.28 because that would be your 2 pi. Yep. So all of these answers are going to be in between those two because they have to be from 0 to 2 pi. Yep. All right. The other thing on the calculator part is your arc length and area of a sector. It feels like it's been months since we did these. Yeah, this is the SOR, right? S equals theta times the radius. That's SOR, that's your arc length. And then area is 1/2 theta times the radius squared. The theta has to be in radians. So if it wasn't in radians, we'd convert it to radians and then you plug it in. You are going to get these in different ways though. It might not just ask for your arc length. Like it could say, find the length given theta is 2.5 and r is 6. Super easy. Literally multiply those together. What's that? 19. Or it could say, find theta given r equals 6 and s equals 19. So then s equals, again, SOR. S equals theta times the radius. S is 19. Theta is what we don't know. Radius is 6. And I would do 19 divided by 6. And I'd get, wait, it would have worked. That's 15. We're still going to stick with the 19 for the second part, but that should have been 15. Okay, this divided by 6, and I get theta is 3.167. So I just do 3.17, or I think that says nearest tenth. So it'd be 3.2. Or you could get given the angle and the length, and it's looking for the radius. So obviously you just plug in. You're going to get 2 of the 3 parts. You got to solve for what's missing. Okay, yeah. No. Yep. And even the question will ask for like theta in radians. Yeah. The whole test is radians, which means after you reset your calculator, you get to leave it. Because remember, we put it in radians when we reset. Nope. All right, then area. Okay, so same thing. You could get given theta is, I don't know, 4.5. You could get your radius is 2. So I'd get area equals 1/2 4.5 times 2 squared. So 1/2 4.5 times 4, and literally you can use your calculator to multiply that whole thing out. And you'd get 9. Duh, because 1/2 of 4 is 2. And whatever the unit squared, if they gave you units. Or it could say find R given area equals 9 and theta equals 4.5. That's what I gave you. Yeah. And so I'd get 9 equals 1/2 4.5 times R squared. I could multiply everything by 2. 18 equals 4.5 R squared. Divide both sides by 4.5. R squared equals 4, and R would equal 2.
You also multiply the 1/2 to 4.5.
Yeah, you can do it in any order you want. And you have your calculator, yeah. Same thing, yeah. You might be given information about, like, so let's say I gave you the area and you had to get to the arc length, you could cross these over. So if I said area equals 12.5, theta equals 6.5, find the arc length. How would you do that? So I'm going to use the first formula to solve for R. So 12.5, 1/2, 6.5, R squared. So multiply by 2, or multiply by 1/2 there, so 12.5 times 2, 25 equals 6.5 R squared. Divide both sides by 6.5. R squared equals 3.846, so on and so forth. Square root both sides. R is 1.96, and then I would use that to find the length. Theta is still 6.5, and now my R is 1.96. So you're going to get a mix of information there. Just be so comfortable with those formulas that if you're given 2 of the 3 things, you could work your way around to find the other one. And all of that's calculator. So finding the trig functions of the angles, finding the angles given the trig function, and then arc length and area of a sector are the calculator portions. And you're going to start with that. 7 questions and you'll start with that. Questions, that's all over the place. Questions on that part. Okay, then comes the non-calc portion. And this is all unit circle based. So this is find the sine of an angle, the cosine of an angle, the tangent of an angle, the secant, the cosecant, and the secant of an angle. And all unit circle based or coterminals of your unit circle. So this is where you want to definitely, not only, I would say, obviously use your unit circle, but they're not all going to be on your unit circle for that reason because you're going to get given it. So remember, every over 6 has the coordinate point, that's root 3 over 2 and 1/2. And the tangent is root 3 over 3. Every over 4 is root 2 over 2 and root 2 over 2. And the tangent is 1. Every over 3 is 1/2 and root 3 over 2. And the tangent is root 3. If you just know that part, that's literally half the battle. That means I could put something like 341 pi over 3, and you should already be able to tell me the value of the sign there would be root 3 over 2. Then all you got to do is figure out your positive negative sign. Does that make sense? So just knowing the unit circle denominators of your special angles, your reference angles, helps you so much with all the rest of it. So remember, the trick is the even whole numbers are on the right, the odds are on the left, and then this is your halfway mark. Is it less than 1/2 or is it bigger than 1/2? And that tells you where to stop. So if I did have, you probably won't have 341 divided by 3, but let's say I did. This would be 113 and 2/3. Where's the 113 take you? On the left. The 2/3 says go past the halfway point and stop in the 4th quadrant. So that coordinate point is negative root 3 over 2. What if it had a negative in front of it? How does that change the direction? I'm going to go up instead. This would actually be a positive root 3 over 2 because it would be in the first quadrant. So be prepared for positives, be prepared for negatives, any of those, right? Over 2s, over 3s, over 4s, over 6s, and whole numbers, like that kind of stuff. It's all going to be reference angle based. Yeah.
Do we have YouTube?
Yeah.
Wires?
Yeah. No, it's printed on the test. Yep.
Wait, so when there's a negative in front, that's positive?
If it's negative, no, not necessarily any answer. The negative just says, so the odd part still says start here, but instead of working my way in my normal positive direction, I'd go in the negative direction and it's past the half, so it puts it in the first quadrant. Then the second part of the non-calculator part are the inverses. So I'm going to give you the trig function and you're going to, I'm going to give you the trig function and you're going to tell me, let's say it's 1/2, okay? Or it would look like this, cosine of s equals 1/2. Tell me what s is. So you'd go to your unit circle. I'd find everywhere the x value is a positive 1/2, which is at the over 3 here, and the over 3 here. This is pi over 3. This is 5 pi over 3. Yep.
Would you specify, like, are you going to specify, like, you're living for degrees or?
Everything's in radians. So it would say 0 to 2 pi, which is your hint. It's supposed to be in radians, but I'm telling you right now, everything's in radians. Yep. If it had said cosine of s equals plus and minus 1, what's the answer? Where's your x a positive 1? At 0. Where is it negative 1? Or, what's that in radians?
Pi.
Yep. If I said tangent of s equals plus and minus 1, what's your answers? Those are undefined. Tangent's undefined there. Where's tangent 1? All the over 4s. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Right? All the over 4s would be 1. Same for cotangent. Like if it said cotangent of s is plus and minus 1. It's all the same answers. Questions? Okay, I'm going to let you